Down here at the bottom is the second section. And what we did is for these ionic compounds, the only thing that you have to do is you have to name the metal, and then the second non-metal will change to the ending of an IDE. And just reusing these over and over again, because there's not that many, you will understand how to use these all the time. They do turn an IDE and a covalent bond, but the difference in a covalent bond and an ionic bond, first of all, is what they're made of. Remember, ionic is a metal and a non-metal, where a covalent is two non-metals. But the second thing of naming is with the ionic bonds, you don't have to worry about the subscripts. In the covalent bonds, you know, you use the prefixes tri and di and tetra. On this one, you do not have to. So if it's an ionic, if it's a metal and a non-metal, you just name the metal, and then you change the non-metal to end in IDE. So you can check over these really quickly and if you need to, and then make sure you have those answers. Okay. On the back side, or on the second side, we have to steps. Step 1 is I'm going to identify the elements. Step 2 is I'm going to get their oxidation numbers. Step 3 is I'm going to use subscripts to balance charges in the compound are neutral. Okay. The compound has to be neutral. So to get the oxidation numbers, I have to go to the periodic table. So you see that this is, we have the periodic table labeled. You know, you have all the other stuff labeled on yours, but these are the oxidation numbers, right? This one has an oxidation number of 0. And then the transition metals, their oxidation numbers will vary, just like their transition just their valence electrons. So potassium sulfide, potassium is K and sulfide or sulfur, and that is S. So potassium has a 1 plus charge. Sulfur has a 2 minus charge. So we have to do something called crisscross applesauce. You bring this one down here and you bring that one down here. Now remember, when I write this, I don't have to leave that 1 on there, so I could just write it as a K2S. That's all I have to do. So from now on, I'm going to do my work in here and then put my final compound out there. I wasn't thinking. If I look over here at beryllium oxide, I have to get the beryllium is 2 plus. Okay, oxygen is a 2 minus. Well, in that case, you do a 2 and a 2, and that's going to reduce to a 1-to-1 ratio. So beryllium oxide is going to be a 1-to-1 because you have a 2-to-2. So 2-to-2, just like if you had 2 over 2 as a fraction, you would reduce that to 1 over 1. So that's how you do that. The next one, magnesium oxide. So magnesium, I'm going to do my work here, is a +2. Oxygen is a -2. Again, same thing. So it's just MgO because it's a 2-2 ratio, which reduces to a 1-1 ratio. Barium iodide. Barium is a 2 plus. If you see it on your periodic table, barium's number 56. It's in this family, 2 plus. And then iodide, is iodine, and that's a 1 minus. So now we have to do crisscross applesauce. So we bring the 2 down here and we bring the 1 here. So basically you're saying if I have 1 barium with 2 positive charges, that's a 1 times 2, so that's going to give barium a 2 plus charge. 2 times -1 is a -2 charge, so that's balanced. So barium iodide would be written like that. All right, let's look at sodium nitride. Sodium nitride is sodium, which is Na, and nitrogen. Na has a 1 plus charge. Nitrogen has a 3 minus charge. So we have to crisscross applesauce. The 3 comes down, the 1 comes down here. So on this side, sodium is a +3, nitrogen is a -3 because I have 3 sodiums with 3 positive with a positive charge each, and I have 1 nitrogen that has a -3 charge. So my charges are equal. So I'm going to have an Na3N. That is my formula. Potassium nitride. Potassium, nitrogen. Nitrogen we just found had -3. Potassium has a +1, excuse me. So again, crisscross applesauce. K3N. Barium phosphide. Oops, I said I was going to do my work here. Barium has a 2+ charge. Phosphorus has a 3- charge. So you're going to crisscross applesauce. The 2's coming down, the 3's coming down. So if I multiply here, this is going to give me 3 bariums, each with 2 positive charges. That would give barium a +6. Phosphide is 2 times -3, so that's going to be -6. So that would equal out to be 0. So Ba3P2 would be the balanced ionic formula. Aluminum bromide, aluminum and bromine are my 2 elements. Aluminum has a +3, bromine has a -1, so I have to crisscross applesauce. That's going to bring the 3 down. That's going to bring the 1 down. +3, -3. Aluminum bromide would be written like that. All right, calcium phosphide. Oops, here I go again. Let me get ahead of myself. Calcium is a +2. Phosphorus is a -3. So I have to crisscross applesauce. The 3 comes down, the 2 comes down. So on this side I have a +6. Now I have a -6. So that's going to give me Ca3P2. All right, magnesium nitride. Magnesium has a 2+ charge. Nitrogen has a 3- charge. Crisscross applesauce. Magnesium 3N2. Aluminum phosphide. Aluminum is a 3+. Phosphorus is a 3-. If I crisscross applesauce that, it's going to be a 3:3 ratio, and a 3:3 is going to reduce to a 1:1. So we just do, looks like ALP. All right, beryllium fluoride. Beryllium has a 2+ charge. Fluorine has a -1 charge. I have to crisscross applesauce, and I end up with BeF2. All right, calcium chloride. Ca has a 2+ charge. Chlorine has a -1 charge. Crisscross is going to give me a Ca1, so I don't put the 1, Cl2. Strontium is a 2+. Nitrogen is a 3-. To balance my charges, I have to put the 3 here and the 2 there. +6, -6. Strontium 3, nitrogen 2. All right, barium nitride. Oops, I did it again. Barium is 2+. Nitrogen is 3-. I have to bring those, crisscross them, so I'm going to end up with Ba3N2. All right, beryllium chloride. Beryllium is a 2+. Chlorine is a 1-. I crisscross beryllium chloride like that. Okay, let's see if I can get that a little clearer. It looks fuzzy to me on the screen. A little bit better. All right, calcium oxide. Calcium has a 2+ charge. Oxygen has a 2-. So that balances out already. CaO, it's a 1:1 ratio. Potassium oxide is a 1+, oxygen 2-. So we have to crisscross these, 2, 1, so it'll be a K2O. All right, potassium bromide is a 1+. Bromine is a 1-, so it balances out. Magnesium phosphide. Magnesium is a 2+. Oops, I did it again. And phosphorus is a, we'll do it over here. Magnesium's a 2+. Phosphorus is a 3-. So I'm going to crisscross 3 and 2. So I'm going to end up with, because I don't write the charges on the formulas, Mg3P2. Lithium chloride. Lithium is a +1. Chlorine is a -1, so it balances. Sodium chloride. Sodium is a +1. Chlorine is 1, so sodium chloride it is. And that's that. Pretty. And that's that page. The next thing we'll go over is the other page. So look for the next video for that.